Okay, so the second type of problem you may run into, or not run into, the second type of problem you're going to have to do is investigating a function. There's three graphs that I'm going to ask you to, or three functions that I'm going to ask you to investigate. You have to do that by creating a table so that you can sketch the graph and then answering the questions that follow. So we'll go ahead and jump in using the templates on the next page. Sometimes I think the hardest part about getting started is figuring out what point values to choose. So if you're unsure, maybe you just start with some basic points like -2, -1, 0, 1, and 2. And if we try those 5 points and calculate our outputs, that may be a good place to start. So if I plug in -2 into the function I see up above, I'm going to get 1/4. If I plug in -1, I get 1. If I plug in 0, I get undefined. Now, we're not sure what that means right now. We just know that it means that there's no point there. And then if I plug in 1, I get +1. And if I plug in 2, I get +1/4. So maybe you're already starting to notice some symmetry just looking at the table. So if I graph those points, -2, 1/4, -1, 1, 1, 1, and 2 1/4. So maybe you try going out a little bit further. So you say, okay, well, what happens if I do 3? Well, I'd get 1/9. Well, that's going to put me even closer to the y-axis. What if I tried 6? Then I'm going to get 1/36. Now, that's going to be really hard for me to graph. But hopefully what you're starting to realize is that if I look at either side of this graph, what's happening is we have this asymptote at y = 0. And we end up with this function that's starting to look like that. Now, I've got to do a little more investigating between -1 and 1. But what I can already start to form here is an idea about the fact that I have this asymptote right here that's going to help guide my function. So the next thing I'm going to try to figure out is what's going on between -1 and 1. So what if I plug in -1/2 and then +1/2? So if I plug in -1/2, I'm going to get 1/- (-1/2) squared, which is 1/1/4, which is actually 4. And then if I do the same thing with +1/2, I also get 4. So at 1/2, my value is 4. So I see a big jump there. 1/2 and -1/2, my value is 4. Now what happens if I plug in, let's do 1/4. Okay, so that would be 1/1/4 squared, which is 1/1/16, which ends up just being 16. Now I can't even graph that, but what I'm starting to notice is that the closer I get to 0, the higher my output is. If I plugged in something like 1/10, I'm going to get 1/1/10 squared, which is 1/100, which ends up being 100. Now we know we can never reach x = 0. So that's another indication that we've got another asymptote here. Okay, so we've got this asymptote at x = 0. And then what I see is my graph is going to sort of take off and get real close to x = 0, but it's never actually going to reach x = 0. So we've got a graph that's kind of like what we were graphing in class last time. So take a look at the graph and see if you can answer the questions from the previous slide. And then I'll start the video back up and we can talk about the answers to those questions. All right, so as far as shape goes, you could really describe that in any way you wanted to. It looks a lot like the graph we were graphing with a reciprocal function, except, they're both above the x-axis now. As far as important or any points that can't exist, any trouble points, x = 0 and y = 0 are both trouble areas, and there's asymptotes at both of those places. You have your symmetry right down the middle of the graph vertically, so at x = 0. Any important points? There's not really here. I mean, you could probably, make a case for there being some important points, but there aren't any intercepts. There's no vertex to this. You could talk about 0, 0 being important because that's where the intersection of the two asymptotes are. But as far as important points go, I don't know if I would really describe any one point as having any more importance in this graph than another. There are no intercepts. As x and y or as x increases and decreases, look at your graph. So as x increases, okay, as our x value gets larger, our y value stays real close to 0. And as our x value decreases, as x goes to the left, our y value still stays really close to that y-axis, so it stays close to 0. And then finally, domain is going to be negative infinity to 0 and 0 to infinity, and your range is everything from 0 to infinity. Again, not using any kind of brackets there. Everything is in with parentheses. If you wanted to write that another way, you could say, you know, x cannot be 0, and you could say y is greater than 0. Those are both ways to write that in another way. All right, let's go ahead and try the second one. All right, so our function this time is negative 8 divided by x squared plus 4 plus 2. Once again, if you're having trouble figuring out where to start, you know, maybe we just start with negative 2, negative 1, 0, 1, and 2. And you plug those in and you evaluate. Now, I'm not going to go through that piece of this. Hopefully, you've already tried this, so you have an idea of what your table looks like. But when you do that, you're going to get, when negative 2 is x, you get 1 for y. When x is negative 1, you get 0.4 for y, or 2/5. When x is 0, y is also 0. When x is 1, you get 0.4. And when x is 2, you get 1. So let's graph those points. At negative 2, we have an output of 1. At negative 1, we have an output of 0.4. Then we have 0, 0. Then 1.4. Then 2, 1. Now, again, that might not be enough really, because it kind of almost looks like it could be an absolute value graph or maybe even a quadratic, but we can tell kind of by looking at our function that it's not either of those. So we're going to need some more data. So let's maybe try some values beyond negative 2 and positive 2. So what if I try something like, let's try 3, and then let's try 7, and let's try negative 8, and maybe negative 10, just putting in a variety of numbers here. So go ahead and try those, pause the video if you need to, and come back when you're done. So 3, we get 1.4 approximately. 7, we're gonna get 1.8 approximately. At negative 8, we get about 1.9. At negative 10, we're gonna get about 1.92. So I'm going to try and graph these and see what's happening. Now, I recognize that there's some symmetry here because we're squaring our x value. So whether it's positive or negative, it's always going to come out positive. So I recognize that when I have x is 3, either positive or negative 3 could give me a 1.4. Positive or negative 7 is going to give me 1.8, and so on. So I've actually got two sets of points going on here. So at positive and negative 3, I get 1.4. So that's maybe right about here. I'm going to put that on both sides. At positive or negative 7, I get 1.8, so maybe right about there. At positive or negative 8, I get 1.9. And at positive or negative 10, I'm at like 1.9 again. All right, so hopefully we're starting to get a little bit better of an idea. You could try, you know, if you want another value in there, maybe try plus or minus 5. That's going to give you like 1.7. Plus or minus 4 is going to give you 1.6. So there's just a couple other values in there that might be helpful, just to give you an idea of what's happening in this graph. So tentatively, it kind of looks like, I mean, hopefully you're noticing, looks like there's an asymptote here. Okay? So it looks like we're never going to go past positive 2 on the y-axis. So what's happening is we have this kind of graph that stays really close, and then it sort of kind of makes a beeline towards 0 and then bounces back up away from 0. So we end up with this graph. It sort of looks like a little, like a hill or like a valley almost. Looks like a parabola that was kind of like cut off and then squashed. All right, so we've got a couple different ways we could describe that. So that's a decent graph. We've kind of gotten some good idea of what it looks like. We plotted enough points that we could really get an idea of what this graph is doing. Now, if you haven't already answered the questions, do that and then come back and check your answers. All right, so here's our quick summary then. The shape, you know, you could describe that however you want. We do have an asymptote at y equals 2, so we notice that there's a problem there with y equals 2. We know that y cannot be negative because no matter what we do, we get a positive output when we plug in, whether plug in positive or negative numbers. Really the only important point maybe that I would say there is our 0, 0, because it's kind of like our vertex. It's also our intercepts, which you can see in number 5. Symmetry at x equals 0 again. And then once again, as our x increases or decreases, our outputs, our y, stay close to 2. And we're looking at, way out away from 0, 0. We want to say our outputs are staying close to 2. And then domain is all real numbers domain is all real numbers, so negative infinity to infinity. And then range is between 0 and 2, including 0. So we put the bracket around 0 and the parenthesis around 2 because we can't include 2. All right, last one. Okay, once again, we have a function 4 over x minus 3 plus 2. If you're not sure where to start, go ahead and start with our standard numbers here. Start with -2, -1, 0, 1, and 2. If you haven't already done so, go ahead and do those 4 or 5 values, come back when you're done. So if I plot the points I have here, -2, 1.2 is going to be right about there. -1, 1. 0, 2/3, 1, 0, 2, -2. I don't really have a good idea of what's going on here. It looks a little strange. So I'm going to put a few more points in. I'm going to try, let's see, we'll do 3, 4, 5, 6 and see what that does. So pause the video and come back and see what you have when you're done. All right, so when I plug those in, I get 3 is undefined. I'm going to hold off on figuring out what that is here for just a minute. I get 4 is 6. 5 is 4. And 6 is 3 1/3. Still not entirely sure what's going on, so let's try a few more. I'm going to try some points between -2 or between 2 and 4. So maybe try 2.5. 2, let's do this. Let's do 2.25, 2.5, 2.75, and then come back. So maybe this is starting to look familiar. And then maybe if you need a few more points, we could try 7 and 8, maybe even 9 if you really wanted to. So if you figure out what those are, you're going to get 3 and 2.8. So at 7, we're at 3. At 8, we're at 2.8. And I hope you're starting to see what's happening here. Now, if you need more points, you can put more points in your table. But what's going on is we actually have a function like what we were doing the last time we met. There's going to be a vertical asymptote here at x equals 3. There's a horizontal asymptote at y equals 2. So some of you wondered how we could shift the graph up, and we did that by adding 2 to the end of our function. We see that x minus 3 is still coming from what makes the denominator, or we see that the x equals 3 as our vertical asymptote is still coming from what makes the denominator 0. But we have that same sort of shape occurring there. So we know that we're going to stay really close to the asymptotes, and we can graph our function, and it looks just like it did when we were doing this in class a few, I guess 2 days ago for most of you. All right, so we've got this graph. Now go ahead and fill in the questions and come back and compare your answers with me. All right, so I'll just run you through these really quickly because I think after what we did in class, this should kind of make sense. The shape, again, describe that however you would like. We have asymptotes at x equals 3 and y equals 2, so those values do not make sense. Important points. So you could really say, your important points are your intercepts. You could look at your graph and say, my important points are where the 2 asymptotes intersect, so this point at 3, 2 might be considered an important point. My important points might be that sort of turning point in the actual curve in each of those things. Lots of different ways you can classify those important points. So, that's going to be different for each of you. Symmetry, so let's look at symmetry. Symmetry is going to be at 2 different places on this graph. It could go through, I'm going to try to just sketch this in there, something like that, or it could go something like that. Those 2 are both lines that would be our symmetry lines. And then finally, we have our x and y intercepts. You can take those right from the table. You can actually calculate those since you have the equation. And then as x increases or decreases, our y value stays really close to 2. And again, if you look at your graph, as we go really far away from 0, 0, and we look at these values of x as they keep getting smaller, my y value is staying really close to y equals 2 because of that asymptote. And same thing over here. As my x values continue to get larger and larger, the y values are staying really close to 2 because of the asymptote. And then finally, your domain and range. I've written it 2 ways. I would prefer that you try really hard to write it this way. In fact, on the quiz, I want you to try to write it this way, but if you want to do a second notation, that's okay, and we'll kind of take that into account. So try to write it with the interval notation, but if you have another way that you can describe the domain and range, we would accept that for now as well. All right, let me know if you have any questions.